Professor Arsenal, I think you might be muted.
How about now? You got me?
Yep.
Okay. Oh, sorry, I'm using a new headset and didn't sync the settings. Okay. All right. So today's topic is file input and output, no longer getting everything from the keyboard, but reading things in that already exist and writing things out that will exist in perpetuity. Before we get there, a couple of administrative notes. Everybody, welcome back from spring break. Hope you all had a relaxing time because, as I mentioned beforehand, there's going to be a lot of work from here on out. Lab 7 will be back tomorrow. Homework 5 is out. We're going to talk about homework 5 because I want to get everybody up to speed and clarify a couple of things. And in addition, I've talked to Kevin and Mariah, and they said if you want to ask them about homework 5 during lab tomorrow, that's fine. They will be happy to help you. The first big programming project. Now, programming projects you have 2 weeks to do because they're big and they count a lot of points. That'll come out this Friday. So you do have until next Monday to do the homework, right? The homework is not due Friday. The homework is due next Monday, the 29th. But Project 1 will be out on the street by then, so you want to see if you can get to it. So let's talk about homework 5. Now, if you haven't seen it, it looks pretty scary. It's not as bad as it looks. I want to talk about each of the problems and see if I can explain what's going on. Now, Project 1, problem 1 apparently is confusing a number of people about how you determine the distance, how you calculate this number we give you in the sample output. So here's the bottom line. An anagram is just, anagrams are just two words that are the same letters rearranged. So if two things are going to be anagrams, they have to have the exact same letters just rearranged into a new word. If they're not anagrams, we want you to figure out how many letters have to change in order to make them anagrams. And the way we count is any extra letters, any letter that's in either of the two words that's not in the other one will have to change. And so that is something you'll have to count. Now, let me go to pie chart. Okay, and this is problem 1. Okay. All right. There we go. So writing the pseudocode, right now, the first thing you do is fairly straightforward. You ask the user for 2 words. Okay. And so we'll call it original equals input. I need 2 words.
Oh, Professor Arsenal?
Yes.
Could I ask a quick question?
Certainly.
Are we allowed to use recursion on the homework?
No, not this one. We haven't covered it in class yet.
Okay.
Okay. Input, I need 2 words. All right. Now, remember that anything that comes in with an input statement like this comes in as a single string. So you have to split this string to get a list of 2 words. Okay. So words equal original dot split. And it helps if I spell split right. Okay. Now I have a list of 2 words. Okay. Now what I need to do is compare those 2 words against each other. And the easy way to compare these words, look at each letter in the first word. If it's also in the second word, delete it from both. So in other words, I'm going to erase this. but let's say the example I give, we have spot and we have pots. Okay? Start with the first letter in this word. Look to see if the letter is in this word. Yes, it is. If it is, delete it from both words, and I now have pot and pot. Okay, now take the P. If the P's here and the P's here, delete it from both words, OT and OT. Then the same with the O's. The O is in both words. Now, it doesn't have to be in the same position. Notice the S was not in the same position, but I got rid of it because it's in the word. Because anagram position doesn't matter. It's back that it's in there. And then T and T, and now I have empty string, and I have empty string. Okay, here's the key. If these are an anagram, these two words are anagrams, both strings will be empty when you're done. Okay, if these are anagrams, both strings are empty when you're done. If one or both strings is not empty, they're not anagrams. Okay. Well, let me delete this now because I don't need this example anymore. Like, you understand what I'm getting at. And I'll come back up here. I'm going to take, this is a list. Words is a list of two words. It's going to be easier if I say first word equals words sub 0, and second word equals words sub 1. And these are my words that I'm going to compare. Okay. Now, I have to clarify one thing. I'm going to delete a letter from the word if they matched, right? In my spot and pots, when the S's matched, I deleted the S. But we know we can't modify strings directly. We can't modify strings directly, right? Strings are, the term is immutable. We'll cover that later. But we know, we talked about before spring break, you can't modify a string directly. You have to do something so that you can modify that, and that is you convert it into a list. So up here with first words, I'm going to say first word list is an empty list. Then for letter in first word, FWL.append letter. Then I'm going to do the same thing here for letter. I need my list first. SWL, second word list, is an empty list. For letter in second word, SWL.append letter. Okay, what this does is this converts first word into a list. And this converts second word into a list. Now, why did we want to do that? Because we can modify a list. We can modify a list. We can't modify a string. So what I'm talking about down here is I compare the words. I look at each letter of the first word. In this case, it's going to be FWL. If it's also in the second word, I delete it from both. So I do something like this. For letter in FWL, okay, for each letter in the list that consists of the letters of the first word, if letter in the second word list, FWL dot delete. Boy, sorry, quick brain fart. I want to get rid of, it's remove letter, SWL dot remove letter. And if they're not in both, then we don't delete them. Now, so what this does is when you get done with this routine, you have gone through and you've identified all the letters that are in both words and you've thrown them out. Now, if these are anagrams, both strings are empty. If one of both strings is not empty, then they're not anagrams. So you'll do something like this. How do I know they're both empty? Well, one way is I could write if, FWL is an empty list and SWL is an empty list. I'm going to do this. If length of FWL plus length of SWL equals 0. Now think about it. An empty list has length 0, and it's the only thing that does. So if this is 0, that's an empty list, and if this is an empty list, that's 0. The only way the only way these two things added together can be 0 is if both of these are empty. So if both of these are empty, we know it's an anagram. So you do something about it's an anagram. Okay. Now, here's the key. Here's what seems to be causing confusion. If it's not an anagram, how do we determine how many changes have to be made, how many letters have to be modified to make these things be anagrams? The metric we use is the sum of the lengths. Okay, the number of letters left in the first word and the number of letters left in the second word combined, those are the things that have to be changed. And I'm going to write this as a comment because this is not directly code, but basically return the length of the first word and the length of the second word. That's the number of letters that have to be changed. So when in the instructions for problem 1, we say this needs 3 letters changed, this needs 4 letters changed, this needs 1 letter changed, the way we're getting that is when everything is done, when all the letters that are in both are thrown out, how many letters we have left total, that's how many things would have to change. That's how we get that number. So like I said, there's a bunch of confusion. People already asking, how did we get 2 for this and 3 for that or something else? This is what we're doing. So this is a general guide for doing problem 1. Now, you certainly don't have to do it this way. If you think of other ways to do it, they would probably be fine. This is not, the mandatory work. This is just a way that makes sense to me and to us when we were thinking about writing out this problem. Okay, the keynotes to this are, okay, we all know by now, you get your 2 words, you split them into a list. Now we have the 2 words. Since we're going to edit these, we're going to modify these, we're going to, take letters out of strings, and we know we can't do that. We convert it into a list because we can take things out of lists. And the goal is, if anything's in both, we delete it from both. When we're done, if we have 2 empty lists, it's an anagram. If we don't have 2 empty lists, it's not an anagram, and the number of things we would have to change is the number of things left in both lists. Okay? So that's sort of what's intended on problem 1 in the homework, and that's a hint at how to go toward it. Now, I'm not going to talk a lot about problem 2 right now. It's actually fairly straightforward. This is your starting data structure. This highlighted thing here, the notes, that is your data structure. And basically what you're going to do is you're going to ask the user where to start, and you're just going to work through this data structure from the starting point following the pattern in this circle above, and you're going to go from there. That's all there is to it. It's pretty straightforward. Use this as your data structure, and then go through that list in an order that this one tells you. Problem 3. Problem 3 looks imposing because of all the graphics. The important thing about problem 3 right now is we haven't covered it, okay? Problem 3 requires two-dimensional lists, which are Wednesday's topic. So I'm going to tell you it's okay working on homework 5 to put problem 3 away until after we cover two-dimensional lists, multi-dimensional lists actually, in Wednesday's lecture. Now, again, I've talked to Kevin and Mariah. If you want to jump on this quickly, and if you want to get ahead, and if you have questions tomorrow about it because of work you've done on your own, they'll be happy to help you tomorrow. But really, problem 3, it's okay to wait till after Wednesday's lecture because that's the topic. The reason we're behind the major section is when I do exams, the week of the exam, we didn't do anything. Monday was review, Wednesday was the exam, and we didn't cover any new topics. When the majors took their exam the following week, their exam was a take-home exam, and they had 2 full lectures with new material, which is why they're a little ahead of us, but that's okay. I know this is going to happen, and we can deal with it. So, at any rate, problem 3, don't let the graphics get to you. It's not as hard as it looks. However, we won't have covered two-dimensional lists until Wednesday, so it's okay to say we'll worry about that then. 4 is fairly straightforward. You're just looking through strings to see if the alphabet appears in order. If letters appear in order, all 26 of them, it's string processing. It's going through a string, item by item, element by element, to see if the next letter is what you want. It's actually fairly straightforward, and that's it. So I did want to go over that since we've all had a break and we're coming back. I've gone through, as I said, I saw some questions already on project 1, on problem 1 on Discord. So I wanted to give you an illustration of what we're looking for and why there and how it's coming out. 2 is actually, if you follow that list and use that data structure, you're fine. 3 we'll get to on Wednesday, and 4 is fairly straightforward. So that's homework 5. And as I said, Kevin and Mariah have said if you have questions about it, they'll be happy to talk to you about it tomorrow in lab as well. So let's get back to the lecture. A software development tip. Here is a hint. This is actually going to be on test 2. It's always on test 2 every semester. It's kind of a freebie. The software development tip we emphasize is test as you go. You have been writing things as functions. You've been breaking your code up and writing functions that do different things. Going forward, you will be writing more and more functions. What you should always do is test a function when you have it written. Don't wait to test the whole program. If you wait to test the whole program, you're going to have a subtle bug and you're not going to know where it is. If you write a function and put in what we call a stub, just call and test that function by itself, you will know whether that function works or whether that function doesn't work. And if it doesn't work, you can fix it right then and there. You don't have to come back to it later. Now, nobody's perfect. I'm not going to guarantee you're not going to make a subtle bug that you didn't catch when you tested it, and it'll pop up later and it'll drive us all nuts trying to find it. That's likely to happen. But the key is when you write a function, test that function before you move on. And then when you know that function's right, move on to the next function or the main program or whatever. Test as you go. There's always a multiple choice question, so 3 points probably, that will say, what's the best way to develop software? Just throw it all together and hope it works at the end, or test as you go. The right answer is test as you go. In all seriousness, it's such an important step. It's such an important pattern to follow. That's why we do this. Okay. And we're going to try to do that as we work through the next few days in class. Up until now, everything we've done, the input comes from the keyboard, the user types it in, and all the output goes to the screen. Type in, get a result on the screen. Okay. That's useful for some things, but for a lot of other stuff, it's not useful. You need to get the data that's already been processed by somebody else. You need to store your results somewhere so somebody can use them. Okay. One of the things to remember when you're inputting from the screen, from the keyboard, is, as I talked about in problem 1 from homework 5, everything comes in as a string. If you want it to be something that's not a string, in our case, 2 different words, you have to cast it to another type. You can split it into a list. You can convert it to an integer. You can convert it to a float. You can do whatever. And then we've talked about printing. By the way, I noticed in the example in homework 5, if you look at the dot format thing, all that is making the output look pretty. The code, again, can be something different. We didn't talk about dot format. We talked about F strings. All that line is making the output look pretty in the homework. Don't worry about it. You can get that. You can use F strings. You can do whatever. So this is just, making your output look pretty enough for the user. But that's limited, okay? Don't ask the user to type in data over and over and over, okay? Arsenal's going to vent. I registered for my first COVID vaccine this morning. Yay, I actually have a shot next week. I won't name the grocery store, Safeway, listed the thing. We have openings. We have an opening Saturday at 2 o'clock. I'll take that opening. Great. Fill in the form. Fill in the form. Too bad somebody grabbed that spot. It's not available anymore. Okay, I'll take 3 o'clock on Saturday. Great. Fill in the form. Wait a minute. Why do I have to fill this form in again? I just typed all this nonsense. I don't want to type my driver's license and address and everything else in again. Well, guess what? I get to. Okay. And guess what? By the time I type it all in again, somebody's taking that appointment too. Try again. So finally wound up next Thursday. But, So the point is, once the user's typed it in once, the user doesn't want to type it in over and over. The user's going to be very annoyed with you and think you don't develop software very well. Safeway. It's not theirs. They use somebody else's, but nonetheless, they get the blame. So save your program results for later use. Don't make the user type it in again, okay? I get it the first time. I want the 2 o'clock appointment on Saturday. I type all that information in. Somebody else wants the 2 o'clock appointment. They type faster than I do. They win. I can live with that. Then when I want the 3 o'clock appointment, it would be really good if you just took what I already typed in and applied it, and nobody could beat me to the 3 o'clock appointment. Okay, so this is what we're going to do. Python, like most languages, allows you to do that, and that's the topic of today's language. Okay. Now, bear in mind that computers have directory systems, and different files are in different directories, and I'm going to show you an example later on of Mac versus Windows and what it means for Python. Anytime you're doing file input and output, you have to know the directory in which the file exists so that PyCharm or GL or whatever can find it. Now, every computer has a variable, an environment variable is what it's called the Python path, and it's different from every one. But you can set that and tell Python exactly where you want Python to look for any files you name. And Python will follow this path, and we'll talk about PyCharm in a minute. However, a warning for this class and a suggestion. The easiest thing to do is make sure your data files are in the directory that you're working in, or specify the full path in the file system. Let's look at an example. We're going to read in, this out of the way, I created a simple file called integers.txt. Okay, integers.txt contains a bunch of integers on a few lines in a file. It's for illustration processes. What I want to do is read in this file, which is called integers.txt, and I want to be able to do some things with the integers. Okay. If we come down here to my terminal window on my Mac, Mac OS is similar. It's not identical to Linux, but it's very similar. It uses the same basic commands. So this is the Z shell. Okay. And I can see that right now I am in a directory that my Mac says is users, Alfred Arsenal, PyCharm project, spring 2021. This is all my stuff for this semester in this directory. And as you can see, I can list the files, and I have some .text, which happens to be data files. I just arbitrarily named them .text. And the coding.py files that we've been talking about, which have the various code. And I've got something called CSV, which we may or may not have time to get to today. Okay, so these are where my files are. And you can see right here, integers.txt is in this directory. And this directory, again, has the path users, Alfred Arsenal, PyCharm project, spring 2021. Okay, and this is what integers.txt looks like. Let's go back to the code. Let's mark this off. Yes, I will post this all on GitHub when we're finished today. So I want to mark off this section to say that's the end of the stuff I was talking about for homework 5. File IO. The first thing I have to do to use any file, I have to open it. This tells Python, and Python tells the operating system what file I want to use. And there are a bunch of different things. So if you see something slightly different, different syntax, different semantics, it's okay. But the way we do this, the easiest thing to do has the following syntax. With open, in this case, I'm going to call it integers.txt, R as F. Okay. So the syntax with says, okay, this is what we're going to do. We're going to open a file. What file are we going to open? We have to put it in quotes, integers.txt. Now, this is saying this is in the current directory. Hey, Python, hey, macOS, you don't have to go looking anywhere for this file. This file is in the current directory. And that's what I did down here in the terminal was I verified that the March 22 coding.py file and the integers.txt file are in the same directory. So this is the simplest case, put everything in the same directory, you'll be fine. R means I'm going to read that file. And we're going to talk about modes in a minute. I got slides on it, but this just says we're going to use this file to read. We're not going to write, we're just going to read. This name is what's called a handle. It's a file handle, it's a name. In other words, I don't have to refer to this as integers.txt. In my code, I'm just going to call it F. Anytime I see F in my code as a variable name, it means this file. So that's the syntax here. I have with, I have open, and then in parentheses, I have the file name in double quotes or in single or double quotes. Then the mode, I'm going to read, I'm not going to write, as F. Okay. And I'm going to say data equals F dot read. Okay. Now, let's execute this code in a Python console. And make sure it works and see what it does. So I'm just going to run this in a Python console. What does data look like? Okay. You know what integers.txt looks like. Here is what I get as data. Now you'll notice this single quote and this single quote says this is a string. It read the whole file, everything, the line 147, the 258, the 369, the 4710. It read everything as a single string. And that's what this statement does. When I say f.read, it reads the entire file as a single string. Okay. Now, you know, the \n means new line. Okay, let's go back at this original. It read the 1, the 4, the 7, the new line, the 2, the 5, the 8, the new line, the 3, the 6, the 9, the new line, the 4, the 7, the 10, the new line. Okay, so that statement with open at data equals f dot read, that read the entire file as a single string. Okay. Now, I didn't have to do that. Let's comment this out. What if I only wanted to read a single line of that file? Well, I'm going to say data line equals f dot read line. Okay. And now what we're going to do is we're going to see this. And we're going to see the data line is exactly one line of the file. It's the first line of the file up to and including the new line character. So this tells us that read line reads one line of the file up to and including new line. Okay. Notice everything is still a string. In other words, when we did read, okay, when we did read, that read the entire file as a string. When we did read line, that read a line of the file as a string. There is one more option if we want to do reading. Okay, and that is we can read multiple lines. And we can read the entire file into into a list of strings. Let me type this and then I'll try this again. Hopefully in something remotely understandable. You'll notice here, I didn't say read line, I said read lines with an S. What happens there okay, what did I do wrong? File 4, line 4. Oh, I probably have I misspelled read lines is exactly what I did. Sorry about that. Let's try this again. There we go. Now, data lines. Now you will see that this is a list. There's the first element of the list, the first line of data up to and including new line. There's the next line of the file. Pardon me, I had to sneeze there. There's another line of a file. And there's the next line of the file. So read lines reads the entire file into a list with one line per list element. Okay, so we have three different choices: read whole file, read line, read one line of the file, read lines. So this is what happens when we read in a file. Now again, everything is a string. So let's go back and we're just going to illustrate what happens next. We're going to use read. Okay, so we're going to go back and we're going to read the entire file in. Let's go back. And we see that data now has this list, the string rather, that's the entire file. Well, now I need to split that string, okay? And so the first thing I can do, and remember, I have to be indented because I'm under, well, the easiest thing is to be indented because I have to use, this is all while the file is open. Let me come down here beyond this comment. Okay, now what I'm going to do is I'm going to split that. It's called data, right? So I'm going to say lines equal data.split. Now I only want it split on the new line character, right? In order to split this into a group of lines, typo. Not gonna work. There we go. Now I've created this list of lines, and I've also thrown away the new line characters. So effectively, using read and then splitting on the new line character gives me the same function, give you the same results as read lines. So you can do anything you want with this in terms, it's just a matter of you knowing what you're reading in with your read statement and what you're going to do about it. Now, remember, these are strings, and I want to split each line in this into its component parts so I can do something with it. I'm going to sum each line. Okay. So now what I'm going to do is, sorry, I didn't fix the typo here. So for line in lines, that is for each, for the 147, for the 258, for the 369, and the 4710, numbers equal line dot split. For now, I'm just going to test as I go, and I'm going to print numbers. Okay. And here I'm going to split on blank space because that gives me the getting rid of those spaces between the 1, the 4, and the 7. And now you can see I have, this is the first one, 147, the second one, 258, the third one, 369, the fourth one, 4710. I've got this extraneous thing which we'll worry about later. Okay. So now I want to get rid of print numbers. That was not needed. That was just to show you what's happening right here. What I have is this list of 1, 4, and 7. I now need to convert that. I want to convert each of these to an actual integer value, and then I want to sum the three of them. So what I'm going to do is for number in, let's start with sum equals 0. For number in numbers, sum plus equals int number, print the sum of numbers. Let's fix this. I'm not going to bother printing that. It causes me pain. The sum is, and then sum. Okay. Now let's go back and execute this code, testing as we go. Okay. And now we can see that we've summed the 4 lines. And we got 15, 12, 18, 21, 15, 1, 147 is 12, 258 is 15, 369 is 18, 4710 is 21. What happened is there's actually an end of file character in the integers.txt down here that I needed to get rid of that I didn't get rid of. So there was an extra end of file character down here that caused there to be one too many. Had I just deleted it and had the file look like that, and now I can run the same thing, it'll all work, it'll be fine. Okay, let's get back to the slides and summarize what we've talked about. We read from the file, that's R. We're going to get to write later. We read in, we talked about using read. Come back to that one in a minute. Come back to that one in a minute. Reading, here we go. This is the one I was looking for. So with open, the file name, and again, if it's in the same directory, this is what you need. Read mode as F, the handle, the variable name you're going to use to refer to this file in the program. This reads in the entire file. This reads everything in with a list of strings. This reads a single line from the file. Okay, so that's how you read. Important point, if the file does not exist, okay, if the file does not exist, you will get an error message. What do I mean by that? I'm going to change the name. I had verified that integers.txt is in this directory. I'm going to misspell it. There is no file with that name when I read it. And now what's going to happen is if I try to read from a file that doesn't exist, Python will say there is no such file or directory. Okay. If you get this message, it tells you that there's no file by that name in that directory. So one of two things is happening. You misspelled the file name. Okay, fine. In this case, this is what I did. Or you mentioned a directory that doesn't exist. Okay. Now, using Mac OS, if I remember right, we're going to find out. The full path name of this file is users Alfred Arsenal PyCharm projects spring 2021. Okay. And so in this case, presuming I haven't made a typo, and I'm not taking odds on that one, it will work as, this will work as well. And indeed it does, because I actually remembered to get it right. Okay, so this is the case of giving it the full path name in your directory, in your operating system. Now, this is a Mac. Let me go back to the slides and cover something. And I realize this doesn't come across very well, but I will try. This is an example of what I was just talking about on the left side of this slide on a Mac. With open, and then I gave it the name of the file, you know, my path name, which, as I said, on my Mac, it just happens to be users Alfred Arsenal PyCharm products spring 2021 nexttest.py or whatever. This is fine. If you try to do something on Windows, remember that Windows uses backslashes. When I say slash, I mean from the upper right to the lower left. So this is a forward slash or a slash on a Mac, upper right to lower left. Upper left to lower right is called a backslash, and that is what Windows uses. So my file on my Windows system, which is shared with the kid, which was shared with the kids, the file was on C:users.dad PyCharm projects nexttest.py. These backslashes in the Windows path cause problems with Python because those are special characters. Remember, the \n means a new line, the \t means a tab, and all of those other things. And so if you type this statement on Windows like this, what happens is you get an error message that looks like this. And I apologize, it's not really readable, but I was trying to just copy in a screen cap. The bottom line is it doesn't like this file name because it thinks that / is an escape character. It's looking to see, is this \n for new line? Is this \t for tab? Is this / something else? What's going on here? And it sees \u. And Python says, I don't know what a \u is. That's not some defined symbol. And so it dies and you get this error message. Specifically, Unicode escape, it can't, the codec, the coder decoder, can't understand what a \u is and can't understand what a \d is and the whole thing. So if you are using Windows in this class and you give the file path the full name like that, you have to escape it, as in down here. So you would type with open C : \\users //dat / PyCharm projects. The two backslashes together are needed to prevent Python from becoming confused by Windows syntax. Okay, this lets Python say, no, you really mean the Windows / in the Windows path name. So if you are using a Mac or you're doing your coding on Linux, you can ignore this. If you are using Windows and you're going to give the full path name, you have to use these double backslashes together to escape it, to stop Python from being confused. Linux GL is like Mac. It uses the /, which doesn't have to be escaped. But just because your program runs on Mac doesn't necessarily mean it's going to run on GL, because the directory structure is a little bit different. Just a bit, just enough to mess things up. So when you get ready to submit, when we do file IO, make sure that you've got the proper path name. That was just the thing I wanted to illustrate there. With a Mac, because the Mac uses // in the directories, everything's okay. With Windows, because Windows uses backslashes, and backslashes are upper left to lower right, that's \. That's a problem because Python uses those for something else. Okay, that is reading. And now what I want to get to is writing. Now, we said R is for reading. R+ we're going to ignore. That says you want to both read and write. We're going to get to that. That gets really ugly. You will very rarely ever read to and write from the same file in Python for the following reason. You use a W when you want to write to the file. And the first thing that happens is when that file is opened, apologies, had to sneeze again. My allergies are acting up. When you want to write to a file, as soon as Python opens the file, it deletes everything. It erases the file. Okay, the file is still there, but the contents are gone. So if you try to use the same file for reading and writing, you have to be very careful that you don't open it for writing first and delete it, and then you go try to read it, and you're told there's nothing here. It's an empty file. What do you want? Okay. So Python is pretty hardcore about that. When you open a file for write, you delete everything that's already there. If you want to add to what's already there, you ran some code and you did some things. Now you ran some code again and you want to store, it's like chemistry, right? You ran an experiment, you got results, and you stored them in a file. Now you're going to run the experiment again to see if you get the same results. You don't want to erase the first results. You want to add them. Then you run the file in mode A. Mode A is append. Append means do not get rid of the existing file. I don't want you to do that. I want you to add to the end. Then you open for A. Okay. how this works is, sorry, skipping ahead. How this works is any open file has what's called a file pointer. And the file pointer says, this is where the next thing is going to be read. This is where the next thing is going to be written. When you open a file for read, the file pointer goes to the beginning of the file. It says, I'm going to start reading at the beginning of the file. Now, if you read line, you read a single line, then the file pointer goes to the next line and you're ready. If you read or read lines, the file pointer goes all the way to the end of the file. We're done. No more to read. Fine. Easy. If you open for writing, if you open for W mode, then Python puts the file pointer and says, we're going to start writing right here at the beginning of this file. Maybe we didn't want that, but that's what we're going to do. Everything else is gone because we're going to start writing right at the beginning. We're going to overwrite anything that used to be there. It's gone. If you use append or A, then the file pointer starts at the end of the previous file and simply adds to it. Now let's go back to PyCharm and work on this some more. Okay. The nice thing about it is when you open a file for writing, it doesn't have to exist. In other words, Python will create it. So let's go back to my terminal. Nothing up my sleeve. I'm still in the same users Alfred Arsenal PyCharm project spring 2021. This is the list of files that exist. There is nothing in this directory that's going to be called, that's called output, output.txt. That's the file I'm going to create. I'm going to create a file for writing called output.txt. Okay, it doesn't exist yet. So I come back to my Python program and I say with open output.txt for writing as, I don't want to reuse F because that gets confusing. Let's call it out file. This is going to be my output file. Okay. X is the string. Now is the time for the big 10. Y equals to quit losing March Madness games. Z equals my bracket is so broken. Okay. Now what I want to do is write. And just like there's read or read line, there's write or write lines. First thing we're going to do is we're going to execute just this little bit of code. Okay. So I'm going to execute this little bit of code in a console. Fine. Let's look at a terminal. Let's see what files are there. Look, output.txt. Remember the file that didn't exist? When I ran this statement, it created that file for me. So if you try to read from a file that doesn't exist, your program dies, you get a horrible error message, and you get suggested that you should be more careful next time. If you try to open a file for writing that doesn't exist, Python says, I'm cool with that, and open and creates it for you. Let's go back to the console. Okay, now I want to write line. Here is a key. Remember how when you write to the screen, you can print floats, you can print integers, you can print booleans, you can print strings. Not so with file. The only thing you can write to a file is a string. Okay. Out file dot write line X. Out file dot write line Y. Out file dot write line Z. Okay. Let's execute that code. Ah, where did I indent again? It's a problem with the Python console, is figuring out how you get your indentation right. I misspelled it. How did I misspell it? Hang on. Ah, it's plural. Sorry. Let's try this again. And let's fix that indentation problem. There we go. And I didn't open it again. Okay, let's try this again. There we go. That one worked. That's what I get for copying and pasting. Now, let's go see what the file looks like. You'll see that I have my file output.txt. Well, Mac is like Linux, it's like GL. So let's just cat output.txt. Let's see what the contents of the file are. You'll see that since I did not have new lines, it just ran them all together. Here is X. Here is Y. And here is Z. It just ran them all together because there were no new lines at the end of my X, Y, and Z. Now, could I have done that all in one statement since it's plural? It's all right lines? Yep. Providing I don't botch it again. X, Y, Z. Okay. Let's just copy the whole thing. Ah, nope. So this undo. There we go. This will not work. You can write one string at a time. Okay. So this worked because I was writing one string with each statement. This did not work because you can only write one string at a time. If I wanted to make this work this way, write all three in one statement because that was needed Python, then what I would have to do is something like this: outfile dot write lines X plus Y plus Z, and do the string concatenation. Okay, and now we can go back and once again cat output.txt. Well, you're going to have to take my word for it that it erased the previous version and changed it. So we'll prove it. You see what it is now. Just for kicks and grins, let's change that to ACC. Run it here. And you can see that it did indeed change Big Ten to ACC. It got rid of the previous output and it replaced it with this. So that's the point here. In addition to write lines, which is what you're normally going to use, you can also use a write statement, but we try to stay away from that. Generally, we're going to do a write lines. So going back to the slide so I can finally catch up with where we are. We talked about the administrative notes and the software development file. Okay, we talked about input and output in Python. We talked about limited usefulness. We talked about file input. Oh, I wanted to show you the Python path. Opening a file, you have to tell it with open file name mode. R, if you're going to read. W, if you're going to write. A, if you're going to append. R plus will let you read and write. But remember that file pointer? The instant you start writing, wherever that file pointer is where the writing is going to happen. So you will literally overwrite whatever's next in the data file. If you're really, really good and you know character for character what's there in the data file, then R plus is great. It'll let you go in and surgically replace one line without having to redo the whole thing. But you got to be really good. Okay. It's fraught with errors. The easiest thing to do is avoid R plus and read and write separately. You can leave off the mode value. I always try to put the R or the W. If you leave off the mode value, if you just come and say with open, blah, 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 and then no mode. And I delete this R. Read is the default value. Okay, read is the default value. It will work properly and it will read it. So if you leave off the mode, Python defaults to R. You can read the file, you can't modify it. I try to always put that R in there, that read mode, to make it clear what I'm doing. But if you leave it off, it will still work. Again, W, you get a new empty file. A does not erase any existing content. It just moves the pointer to the end of the existing file and adds from there. We haven't shown that yet, but it does. Append is just like write in the sense that if you open a file for append, and it doesn't exist, not a problem. Python will be happy to create a new one for you. Okay, so append and write. If you list a file that doesn't exist, not a problem, no error, Python creates it for you. If you list a file that doesn't exist for read, Python says, I don't know how to do this, and so it dies on you. A note here, everything we've read are characters, are text characters that comes in as strings, okay? In this class, that's all we're going to do. Everything we're going to read in from files, everything we're going to write to files are text characters that make up strings and strings only, okay? There are such things in Python as binary files that are not text that you can do funky things with. Take 291, you'll learn all about it. We don't cover them in 201 because, again, it's a level of wizardry that you can do bad things to yourself without a lot of difficulty. Okay, 291 will teach all about them. There are binary files, but we're not going to talk about them. We're just going to do text. This is the schematic, the syntax and semantics of reading with open data file name, mode as handle. This is how you're referring to it in the program. f.read, the whole file, read lines, read line. The notion about path names, Mac versus Windows. Windows is a pain in the neck. I've heard that before somewhere. I like Windows. I use Windows. It's interesting. How it works, there's this file pointer that moves around, and that tells you where you're going to read from or write to. An example, this is the integers that we talked about. This is similar to what we did. Instead of adding, I look for the largest. You know how to do that. You know how to do the largest versus sum. Not a problem. If we wanted to write the result to the file, print puts in the output. Write or write lines puts the string on the in the file. And interestingly enough, let's see what happens here. After I fix my smart quotes, missing a smart quote. Now, notice this problem here. Okay, you can guess what's going to happen when I do this. Don't want an indentation problem. Other than the issue that I haven't got the defined, the string 5. Here we go. This will not work with the comma here because you're allowed one string and one string only. Okay. So change that from a comma to a plus. I now have string concatenation, and this will now work. And now I can go to my terminal. I can see that I have a brand new file called results.txt. And I can see the largest integer in the file is 5. And there was not a new line at the end of it, so it stops printing. There is no new line added. Okay, so the difference between write and write lines is what you're normally going to use. They will both only print one string, but write lines is intended for you to do something where you're going to continue doing it in the program. Write is when you intend to only do one write statement. Okay, let me fix that typo. Yeah, I know the one on GitHub is wrong. I'll get that later, but that's a plus. Okay. Now, read from and write to the same file. You can do it a whole bunch of ways. Okay. Here is the safe way to do it. I have a file called dogs.txt. It has some silly little text. I'm going to read it in. I'm going to search for the word dog. And every time I find the word dog, I'm going to replace it with cat. Okay. And this is called dogs.txt. So I'm going to do it this way with open dogs.txt for read as dog file. Text equal dog file dot read. Now I'm just going to split it. List of text equals text dot split for word in list of text if word equals dog, I have to change this. Because remember, with the for each, I can't modify the list. So for word in range length list of text, and I'll make it an I because we're doing this as a for I loop. If list of text sub I equals dog, list of text sub I equals cat. Okay. Now, when this is done, we've made all the changes that we want. So now we're going to write the output. What we're going to do is we're now going to come and end that file. Now, you have to, when you open a file, you have to close it. The with open syntax automatically closes the file when you unindent. In other words, when we go back to the same level as here, right, I don't have to. There is a Python statement that says close the file. I don't have to use it because the with open will automatically close it, which is one of the reasons we use it. It's an easy, lazy way. Now, I'm going to say dogs.text for W as out file. Now remember, I can only write a string at a time. So I have to combine list of text back into a string. So what I'm going to do is I'm going to say out string equals, and I'm just going to use a blank space in between words, dot join list of text. And now I'm going to say out file dot write out string. Okay. Then we will take a look. Okay. Ahead of time, this is what dogs.text looks like. Run it. Now, cat dogs.text. Now, there's an interesting thing. There is no case where the word dog, D-O-G, appeared by itself, and because I required an exact match, there were no hits. So let's change it to dogs. And run the same program. Huh. Oh, because this dog has a period. Okay. It's making me very angry. What I'm going to do is if dog in list of text sub I, I'm going to force this to change one way or the other, change the word to cats. There we go. Finally figured out how to make that change. When you're doing pattern matching like that, you've got to worry about exact strings. And by the way, this is this is key. That's the thing you're going to run into in problem 4 on homework 5, where you have to do pattern matching. Now, you're actually going to have to break down and look at letter sequences. To do this right in this code, that's what I would have done. I would not have looked for that string. I would have looked for letter, letter, letter all combined, and then I would have changed it all to letter at a time too. So that's it. We're out of time for today. This is a case of reading from and writing to the same file. In my case, what I recommend doing, if you're going to do that, it's okay. You can do it. What you should do is do all your reading first, and then after you're done reading, then you can manipulate the data and put everything back as a separate write. Because if I was trying to read in a line at a time and edit a line at a time, I could have done it, but the odds of me making errors is a lot higher. I really wouldn't want to do that, but you can do it, and that's the result. We did not have time. We are going to get into comma-separated values, CSVs, and JSON, JavaScript Object Notation files. A comma-separated value file is something like this. If I have a Google, this was from last semester's programming project 2, right? This is a class grade sheet, obviously with fake students, all from Game of Thrones. Yes, I am a geek. Ned Stark, Robert Baratheon, Jaime Lannister, Catelyn Stark, et cetera, and these are the grades on the projects and tests. And what the students had to do is they had to read this in and process it and figure out what each student's final semester grade was based on the formula. The thing about it is this is a Google Sheet. Now, this could be a Google Sheet. This could be Apple's numbers. This could be Microsoft Excel, anything you want. What you do is you export this as a CSV. In Google Sheets, you pick download. In Numbers, it's export. In Microsoft, it's Excel, it's save as. You say, I want a comma-separated value, CSV, and it saves in a particular format, which if we go back to the directory here, I will see if I can open an existing file and show you what it looks like as soon as I figure out which directory I'm in right now. There we go, PyCharm projects, spring 2021. And I'm looking for spring 2022.csv. There we go. It looks like this. Everything just has a list of commas in it. Everything is separated by a comma, literally. And what we'll talk about next time is how to read that in, get rid of those commas, and treat it as a single file that you can use. So, and then next week, we'll get into JavaScript Object Notation or JSON files. And with that, I kept you 3 minutes over. Apologies, but I wanted to share the thing. And I will see you all on Wednesday. If you have questions, feel free to ask them. If you